Part of this total protection effort is the testing of shipping containers, casks designed to carry radioactive materials. A truck carrying a 22-ton spent fuel cask impacted a 690-ton concrete block at 60 miles per hour. The cask sustained so little damage, it was cleaned up and impacted the second time, but at 84 miles per hour. The cask also survived this more violent crash with only minor damage.
I'm sure most of the people in the country, at least some of us a little older, have seen these Sandia crash test films that they use as propaganda to show the trains and locomotives running into these things. And there's a couple problems there. One is that there was no fuel in any of these things, obviously. Secondly, what they don't tell you on the films is in 3 of the 5 stress tests, the casks actually failed and would have released the radioactive contents if they had them. In fact, the people that were making the films said these cannot be used to demonstrate cask safety. They are merely computer simulations to help us calibrate equipment so that we could measure these in the future. Yet the industry and DOE uses them as the ultimate transportation is safe weapon when the films are phony to begin with.
This same cask and rail car were then positioned over a pool of jet fuel and subjected to an engulfing fire. Surface temperatures exceeded 1400 degrees Fahrenheit, and there was no evidence to indicate that even the combination of the crash and fire would have released excessive amounts of radioactivity into the environment.
Now, DOE has a study out that says if 1% of the material in one transportation cask leaked, it would contaminate up to a 42 square mile area and cost in the neighborhood of billions to clean up. We know that some of the DOE transportation routes and even some of the information we have on routing have appeared on what the FBI calls Middle East terrorist websites. They're very knowledgeable of Yucca Mountain. They're very knowledgeable of the shipping campaign that's going to take place or could take place.
Scientists spent years trying to figure out what would happen to a shipment of nuclear waste in a big accident. Tonight, Dan Burns has details of a test to find out if a nuclear cask can survive the toughest test of all.
Scientists at Sandia Labs in New Mexico smashed a nuclear fuel cask on a truck into a wall. But in one test, the cask proved to be a clear failure, a terrorism test.
One of the casks that was in fact used in the films that we've seen was used as a target for the attack. It was determined that it was possible to penetrate the cask. A hole was produced in the cask about an inch in diameter that would have let out some very small fraction of the contents of the cask.
Here's a better picture. Again, the hole is about 1 inch wide. Radioactive fuel rods usually look like this, clean and straight. Whatever the scientists shot into the cask ripped through the fuel rods inside. Most scientists think nuclear fuel casks can survive any transportation accident without opening. But these pictures prove something a lot of scientists suspected. If terrorists get a hold of a spent fuel shipment, the cask is not going to stop them. Dan Burns, News 3.
There is a problem here, and the issue really is that if your bathtub here is overflowing, rather than bail it out, you assume that you want to stop the water first, and then you figure out how to bail it out. But no, we're in a country where you got the water going full force, and yet we're using a thimble to try and bail it out. And it really has to do with the lack of foresight and kind of thinking this whole problem through and ahead, and what would be the risks of nuclear energy versus not pursuing it. What are the byproducts? How do we manage those? And clearly this whole process has not been very well thought through. It began as a promotional exercise to rationalize nuclear weapons. It's grown now into its own industry. And even though it's been in place 30 or 40, 50 years, all of those questions still remain, that there still is not a solution to the waste problem.